Hey, Algebros! First of all, if you're watching this video, congrats! You survived the first half of the linear relationships unit. Arguably, the harder half of it. As we're going forward, things will start to be a little bit more familiar, and honestly, probably easier to understand. Kind of more feels like math. You'll see. But before we hop into the part about solving linear equations, which this latter half will really focus on, that is, solving something that looks something like this, as in, you have a bunch of stuff in this equation, find x. We need to know how exactly we work with things like this. But that's where the next thing comes in, combining like terms. Now, the term like terms is probably something you've seen before, maybe in this class, maybe in another class. But when you think about like terms, you think of terms that are the same or similar. And we remember that terms are basically when you have an equation like this one right here. The terms are the individual things that are added together. So 3x would be a term, 1 would be a term, 7 would be a term, and being a little bit more technical, this entire thing with parentheses is also a term. But in short, it's just the things that are added together, added or subtracted, I should say. Now, what's the process for adding or combining like terms? Keep in mind that when we mention combining like terms, we're referring to addition or subtraction and never multiplication or division. There's a time and a place for the multiplication and division, but we'll come to that later. So, not these, but yes to these. So, how does that work exactly? Well, if you do have like terms, it's as simple as adding coefficients, but we gotta know what those like terms are. So like terms are terms with exactly the same variable So in short, if you had something like 3x, keep in mind the terminology that 3 is called our coefficient, and x is the variable. For something to be a like term, it doesn't matter if it has the same coefficient, but it must have the same variable. So for example, if I were to list out some like terms for 3x, I could probably give you 4x, negative 5x, 100x, even just x on its own. Because keep in mind, x on its own is nothing more than 1x. But I guess the question for you now is, what about something like x squared? Or x to the power of 4? Are these like terms? The answer is no. Having the exact same variable also means it must have the same exponent. So here, like terms must have the same exponent. Exponent being that tiny number that we have up here. We'll talk a lot more about exponents in great length later. But for now, keep in mind that something like x squared and x to the 4th, those are not like terms. So I'll throw out a different kind of example right here when it comes to identifying and classifying like terms. What if I were to give you a long list of terms, like say 9x, 10x squared, negative x, 5, 9x squared, negative 10x, and let's say a couple more, 3x, 3, and just x squared. If we want to classify these as what are the like terms and what aren't, one good thing to always use is to use symbols for identifying those like terms. Use symbols. What do I mean by that? Well, we know one kind of term is a term that's just x, no exponent. I'm going to put a tiny bracket underneath here. Now, what I'm going to do is as I'm identifying, I'm going to put a tiny bracket underneath everything that has just x as its variable. It's kind of like classifying them as families, or clans, or anything like that. Don't worry, numbers are not gangs. Don't think they're gangs. Don't be really weird about it. Now, how about the rest of them? We've identified another kind of term right here, which is the 10x squared term. What we can do there as well, instead of using a bracket, I'm going to use a squiggly line underneath. So anything that has x squared as its variable, I'm putting a squiggly line under. And finally, we have the constant terms, which are just 5 and 3 with no variable. I'm going to put like a tiny triangle underneath them. Now, obviously, you can use any symbols you want, but this method really helps you to be able to identify those like terms. So here we have simply identified the like terms. And now we can list the 3 kinds of terms. So type 1 consisted of 9x, negative x, negative 10x, and 3x. Type 2 consisted of 10x squared, 9x squared, and just x squared. While type 3 consisted of just 5 and 3. How about if we combine them? So in that case, that would require us to add. So let's say in the case of 9x plus negative x plus negative 10x plus 3x. So what we have to do here is simply add or subtract the coefficients. So how does that work? The coefficients here we can identify as 9, negative 1, negative 10, and 3. And now it's as simple as adding them all together. 9 minus 1 is 8, minus 10 is going to be negative 18, and plus 3, negative 15. So all this is going to equal negative 15 with the respective variable attached. In this case, x. All right? So obviously it doesn't have to be this complicated. We can make these cases very simple when it comes to combining the like terms. So in this example right here, when it comes to combine, let's say a couple of examples. Let's say negative 3x plus 5x. So here, since we have our variable is x, and it's the only kind of variable we have, we just look at our coefficients. So negative 3 plus 5, we know that to be 2. So our answer here will be 2x. How about an example with more of a mix and how that works? Let's take 7a plus 6b minus 5a minus 10b. So in such a case right here, it's good to classify the numbers and the like terms first. So for example, I'm going to put a tiny bracket underneath each of the a terms and a squiggly line under the b terms. So now I'll combine the a terms first. So that's going to be 7 minus 5, which will give us 2 with its variable a on the end. And then we'll combine the b terms, which will have 6 minus 10. That'll be negative 4. So 2a minus 4b. And of course, we can get a little bit more wild with these as time goes along. For example, let's say I did something like this. 5x squared minus 3y plus 7y plus y squared minus 5x squared. So here we have a bunch of different terms. So let's start off by identifying. So start by identifying. So here, the kinds of terms, I see an x squared term, I see a y term, and I also see a y squared term. So let's take it step by step. Starting off with 5x squared. Notice that the coefficients in front of them are 5 and negative 5. But what do we know 5 and negative 5 to be when you add them together? Oh yeah, it's nothing but 0. So one tip you can utilize going forward is that whenever you have like terms with opposite coefficients, like 5 and its negative counterpart, negative 5, they hate each other so much that they just cancel, and you can just slash right through them. Keep in mind, this is only if they have exactly the same coefficient, and you can't do this if they were different. Well, not exactly the same, rather opposite. Okay? So opposite coefficients cancel. All right? For example, negative 3y and 7y don't cancel. You simply add them together as we were doing before, and you'll get 4y. And y squared is all in its lonesome, so does it change? Nope. Comes to the dance as we know it. So those are a couple of examples. With this knowledge in mind, a couple of things to keep in mind at all times are as follows. Number one, still can't do anything. A couple of notes. First of all, is that x plus x squared is something we can't add. Or combine, I should say. So these things are things we cannot combine. And I really don't want to see us doing that because it's a very common pitfall that I don't want y'all to fall into. However, if we did have x times x squared, it's a different story. But we'll worry about that later. Another common mistake that I tend to see is messing up when it comes to canceling like terms. So for example, keep in mind that only cancel with opposite coefficients. Only cancel with opposite coefficients. I think those are the two big ones that I wanted to get out of the way real quick before we hop into a bunch of examples. All right, so the examples in question are ones that I want you guys to do on your own and come prepared for on the next day we have class. So let's do them. Let's say we have x plus y minus 3x plus 5y minus 10x plus 10y. Next example I want you to do is a plus ab plus 7y plus, plus 3a plus 10b minus 2ab. And the third example I want you to do is 7j plus 6k minus 6l plus jkl minus jkl, no comma here, whoops, plus 7j plus 10k minus l. All right, these are the three examples. I want you to have those done by class so we can discuss them. Do your best, because I know this might be a little bit unfamiliar, but with practice, you'll be better than me.